Hey, this is Alex, your favorite teacher in the whole world. Today we're going to talk about composite figures. Yes, but what about composite figures? We're going to find the area for these weird shapes right here. So, we have this weird shape that looks kind of like a steps, like the side view of the staircase, something like that. So, we need to find the area. Why is it so difficult? Because we got to split these composite figures because it's composed out of many different figures. So in this case, you can split it up however you want to. However, you're going to be missing some lengths. Not necessarily missing, but you're going to have to find them, either adding or subtracting from something. So let's go about how I do this. So in this case, I can clearly see that I have a big square right here. Big square. And all of this, whenever I split them up, all of them are going to be either rectangles or square, and the area for that is going to be base times height, or length times width. So in this case, it's a 12 by 12, which is 12 times 12, which is 144. That's the area for that big one. Now, you have another odd shape, kind of like a boot or an L, whatever. So what I did for this one, I got the shape for this one right here. Because I have the labels for those, and if you want, I can draw this on the side and label it. That's a 4 and that's an 8. Well, by the way, these are meters. So at the end, the answer is going to be in meters squared because it's area. So again, base times height, 4 times 8, which gives me 32. Now I'm left over with this piece right here. And if I draw it on the side, I can clearly see that this is 4, but I don't have the measure for the height, but I can look for it. How? If I erase right here, so I can see clearer, I can clearly see that this line right here is 4, is given to me, and also this line right here is 4. If I were to move this line over here, 4 and 4 gives me a total of 8, which is going to be right here. Now, as you can see, this is not proportional because this is also a 4 by 8, and I already did it once, so I know 8 times 4 is 32. Now, if it's a composite figure, all I gotta do is add all of those numbers. So, what I like to do to keep it in a format where I can see everything is put in the numbers, the area of the numbers, where they go. So already 32, 32, then just add them all up. So 144 plus 32 plus 32 gives you
208.
208 meters squared.
We did it.
Any questions on that one?
No.
Now, some of you might have seen this as this rectangle right here and another square right here, which is clearly fine. Also fine because this is a 4 by 4, which is 16. And now you have 4 on this side, 8 plus 4, which gives you 12, and 12 times 4 is 48. And when you add them all up, you also get the same answer.
Oh, yes.
Now, you can do whatever you want as long as you don't miss any parts of this weird shape and add them together. Now, I'm going to do another one. This one is a word problem kind of combination. So let's see what it says. It says, Gretchen draws a pattern to help construct a bow for her sister's doll. So this is the drawing for a bow, and you can see it's like a bow right here. And I did it in black so that you can't see it. I don't know why I did that, but this is a bow. Now, if we continue reading this, it says down here, how many square centimeters of material does Gretchen needs to construct 3 bows? 3 bows. So we're making 3 of them. Not just 1, but 3. That's why it's really important to read the prompt, because if you find the area and you type it in as your answer, you're gonna get it wrong because that's gonna be the area for only one. At the end, you need to multiply it times 3, which is the number of boats that you're constructing. So let's do that. Again, just like on the previous problem, I like to separate my shapes. So I know right here, right from the get-go, I got a rectangle. Length times width, which is 6 times 4, which is 24. That's the area for the rectangle right away. Now, the other shape that I have is this right here, and it's called a trapezoid. For this, we have a reference chart, but the formula for a trapezoid, for the area of a trapezoid, you don't need to memorize it because it will be given to you, but the area is 1/2 B1 plus B2 times the height divided by 2. No, wait, not divided by 2. Not divided by 2, because since I don't like fractions, just like on the triangle formula, I just rewrite this as B1 plus B2 times the height, and then I divide by 2. That's where I got a little messed up right there. So that's the formula to find the area of a trapezoid. That's the area. So all we need to do is set it up. So I'm going to redraw this trapezoid on the side because I want to show you something. I'm going to label it. So if you look at this one right here, we got tick marks. That means that this 10 is congruent with this side. So if this side is 10, what is that side going to be? 10. So this side right here is 10. Now the top is going to be what? This right here.
6.
Is 6. It's labeled right there. So you got to look for those numbers, guys. And by the way, these are centimeters, so the answer is going to be in centimeters squared because it's area again. Now, for the height, we already used this number. We already used this number. We don't care about this number because that was nowhere near the trapezoid. So for the height, we have 5 and we have 5.4. So which one would I use for my height? Which one would I use for my height? And I'm gonna help you kind of see which one you need. So if you think about a pyramid, and I ask you what is the elevation of the pyramid or the height of the pyramid? If you go to the very top of the pyramid, how far are you away from the ground? That's gonna be the height. So is the height gonna be vertical or diagonal? I mean, you're gonna climb the pyramid at a slant height. Let's call it slant height. But is that gonna be the distance from your elevation from the top to the bottom? The elevation from the top to the bottom is gonna be a vertical line. That's gonna be the height. Right now in 7th grade, we don't care about slant height. So whenever you look at this, which one are you going to use for the height of the trapezoid? Because it's on the formula. You got to substitute in. Are you going to use the 5 or the 5.4? Are you going to use this one right here? Or are you going to use this one right here? Again, the distance from the bottom to the top. Straight up. Which one is it? The 5 or the 5.4? The 5, you're going to use the straight up distance. Now we can substitute this into the formula and get the answer for the area. So we're going to do that. So my base 1, this can be B1, B2. It really does not matter because we're adding them anyway. If you add B1 to B2 or if you add B2 to B1, you're going to get the same number. So I'm going to erase right here. We already established that we do not care about this height right there. This length height. So we're going to solve in the values. So B1 is 6 plus, what's my B2?
10.
You add that, and the height is?
16.
The height is?
5.
5. And then you divide by 2. So it's gonna be 16 times 5 divided by 2. What's 16 times 5?
80.
80 divided by 2.
40.
So the area for this one is 40. Am I done?
No.
Yes, because the other side would be 42.
Good job. So that's why I say on the other problem that I like putting my areas inside my figures. I already got my area right here. I got my area right here. Wait, I don't have, oh yeah, it's the same. So just write it down. Don't forget. So what do you do to the areas for the composite figures now?
You add them.
You add them. So 40 and 40 is 80, and 24 is 104. That's the square
Square feet.
centimeters square. Now, that's the area for this right here. Is that my answer? What did this question say? How many votes are we making? 3. So the last step will be to multiply times 3, and you get a total of 312 centimeters square. Questions?
No.
Yeah, have a good day, guys.
You said and.